Welcome to my next video. In this video, I will show how to solve this equation here, this logarithmic uh, equation. So first of all, we have to uh, put everything left and right hand side in the logarithm, so that we get so now we can use the following property to separate this logarithm here on the left hand side. Now we can use the second property here. So, and with this, we can bring these two exponents here inside the logarithm in front of the logarithm. So now we can uh, write this 40 and this number 36 just like this. To perform or to write or use the first property rule here. And the log of 36 can be written as log to the of 6 raised to the power of 2 times logarithm of 5 is equal to the log x raised to the power of 3. Now we can perform or do the first property rule here, and here we can use the second property rule. log 5 plus log 8 multiplied by log 6 plus 2 times log 6 times log 5 is equal to log of x raised to the power of 3. Now I want to distribute log of 6 inside the parentheses here so that we can uh, bring the log of 6 outside uh, outside brackets, because we have here a log of 6, but I want to show this in detail. So we get log of x times log of 5 plus log of 6 times log of 8 plus 2 times log of 6 times log of 5 is equal to log of the logarithm of x raised to the power of 3. Since I don't have mentioned the base here, so it's the logarithm to the base of 10 of x. Whenever we don't mention the base of the logarithm, it's always not always, but in many cases, uh, the base of 10 is meant. So these logarithms here are to the base of 10. Okay, now I can bring these logarithms here outside parentheses so that we get the logarithm of 6 times logarithm of 5 plus the logarithm of 8 plus 2 times the logarithm of 5 is equal to the logarithm of x raised to the power of 3. So now we have here the logarithm of 5, and we have here 2 times logarithm of 5. We can bring them together so that we get 3 times logarithm of 5, and with this we can use the second property here so that we can say that 3 times logarithm of 5 is the same as the logarithm of 5 raised to the power of 3, which is 125. So logarithm of 6 here will be multiplied by the logarithm of 125 plus the logarithm of 8. The bases here are to the base of 10. So on the right hand side that we have the logarithm of x to the power of 3. And now we can use here the first property. When we multiply 125 with 8, we get 1000. 1000. And 1000 is the same as 10 raised to the power of 3. And with this logarithm here, we will get the result will be 3. But how's that? When I write here the logarithm to the base of 10 of 1000 is equal to logarithm to the base 10 of 10 to the raised to the power of 3. So now we can use the second property here and bring this exponent in front of our logarithm. 3 times the logarithm to the base of 10 of 10, and this here equals 1. This gives us 1 because 10 to the 10 raised to the power of 1 give us this argument here. So the result of this will be 3. And in the next step, we will get log to the base of 10 of 6 times 3 is equal to the logarithm, the base of 10 of x raised to the power of 3. So now I can bring this number 3 here inside the logarithm using the first property. The first property, let us recall, first property here was when we this second property here, when we perform the opposite operation here, so that we want to bring this letter b here inside our logarithm, then it becomes the exponent inside the logarithm function. So we get logarithm of to the base of 10, 6 raised to the power of 3 is equal to the logarithm to the base of 10 of x raised to the power of 3. So when we want to get rid of this logarithm here to get our x, then we have to raise both sides with the inverse function here. So when we notice that the e function, the Euler function, has the inverse function as ln of x here. So when I use the inverse function, then we get the exponent here using the second logarithm rule. So we can bring this exponent in front of our logarithm here. So we get x times ln of e, and ln of e is 1. So we get x. So here I have to use um, the inverse function. It's 10 to raised to the power of x here, so logarithm to the base of 10 x raised to the power of 3. So this base cancels with the logarithm, and what remains is 6 raised to the power of 3 on the left hand side, and on the right hand side we get x to the power of 3 here. And by comparison, then we can see that x has to be 6. And this is the final answer. And thank you for watching this video. Leave a like if you did, and say something in the comments, and see you in the next video.